Pydantic AI employs a dependency injection system to integrate external resources and constraints into agent execution, enabling type-safe interaction between the LLM and application-specific logic. This mechanism allows dynamic instructions and tool functions to access runtime dependencies through a structured context object, ensuring both flexibility and validation. We are about to examine how a support agent is configured with dependency injection, structured output validation, and tool registration to handle customer queries in a banking scenario. The setup will demonstrate how dependencies are passed during agent execution and how the output is constrained to a predefined Pydantic model. From data classes, import data class. From Pydantic, import base model, field. From Pydantic AI, import agent, run context. From bank database, import database con. At data class. Class support dependencies, #3. Customer id, int. DB, database con #12. Class support output base model, #13. Support advice. SDR equals field description equals advice returned to the customer. Block card. Bool equals field description equals whether to block the customer's card. Risk. Int equals field description equals risk level of query. G equals 0, La equals 10. Support agent equals agent #1. OpenAI GPT-5 2 #2. Deps type equals support dependencies. Output type equals support output, #9. Instructions equals #4. You are a support agent in our bank. Give the customer support and judge the risk level of their query. At support agent instructions #5. Async def add customer name text. Run context support dependencies, SDR. Customer name equals await CTX, deps, DB. Customer name it equals CTX, deps, customer ID. Return F, the customer's name is customer name R. At support agent tool #6. Async def customer balance. CTX, run context support dependencies, include pending. Bool. Float. Returns the customer's current account balance, #7. Return await CTX, deps, DB, customer balance. ID equals CTX, deps, customer ID. Include pending equals include pending. #11. Async def main. Deps equals support dependency customer. ID equals 123. DB equals database con. Result equals await support agent. Run what is my balance. Deps equals deps #8. Print result, output #10. Support advice equals hello John. Your current account balance, including pending transactions, is $123.45. Block card equals false risk equals 1. Result equals await support agent. Runny just lost my card. Deps equals deps. Print result, output. Support advice equals, I'm sorry to hear that, John. We are temporarily blocking your card to prevent unauthorized transactions. Block card equals true risk equals 8. This code demonstrates a production-grade AI agent pattern using Pydantic AI's dependency injection and structured output systems. The agent acts as a bank support assistant, combining static instructions with dynamic context from a database to provide personalized responses while enforcing strict output validation. The architecture uses a data class, support dependencies, to inject runtime dependencies like customer IDs and database connections into the agent's execution context. This pattern enables clean separation between agent logic and external services, making the system more testable and maintainable. The run context, parameter in both instructions and tool functions, provides type-safe access to these dependencies during execution. Structured output is enforced through a Pydantic model, support output,
that defines the exact schema the LLM must return, including field descriptions and validation constraints. This ensures the agent always produces predictable, machine-readable outputs that can be directly consumed by other systems. The combination of dependency injection for input and structured validation for output creates a robust pipeline that's both flexible and reliable for production use cases. Let's break it down.
From data classes, import data class.
Imports the data class decorator from Python's standard library for creating classes that automatically generate special methods like init and repr.
From Pydantic import base model, field.
Imports base model and field from Pydantic for creating data models with type validation and field customization.
From Pydantic AI import agent, run context.
Imports the agent, class, and run context type from the Pydantic AI package. These are core components for building AI agents, where agent serves as the primary interface for interacting with language models, and run context provides runtime context during agent execution.
From bank database import database con.
Imports the database con class from the bank database module, providing database connectivity functionality for banking operations.
At data class.
Decorates the following class with @data class, enabling automatic generation of boilerplate methods like init, repr, and ec based on the class's annotated attributes. This provides a concise way to define classes primarily used for storing data.
Class support dependencies, #3.
Declares a class named support dependencies with no visible body or inheritance. The comment #3 suggests this is part of a numbered sequence, but the class itself is empty and serves as a placeholder for dependency-related functionality.
DB, database con #12.
Declares a variable named db with type annotation database con, indicating this variable will hold a database connection object. The comment 12 suggests this is line 12 in the source file, but doesn't affect functionality. This is purely a type hint for static analysis and IDE support.
Class support output base model, #13.
Defines a Pydantic model class named support output that inherits from base model, establishing a structured data schema for validation and serialization. The class declaration indicates this will be used to define and enforce the shape of support-related output data in the application.
Support advice. SDR equals field description equals advice returned to the customer.
Declares a string field named support advice with a Pydantic field descriptor that includes a description, advice, returned to the customer. This creates a typed model attribute with metadata for documentation and validation purposes.
Block card. Bool equals field description equals whether to block the customer's card.
Declares a Boolean field named block card with a default value of false and includes a description whether to block the customer's card using Pydantic's field function for metadata. This creates a typed model field that can be used for data validation and serialization.
Risk. Int equals field description equals risk level of query. G equals 0, La equals 10.
Declares an integer field named risk with Pydantic's field function, setting a description risk level of query and constraining the value to be between 0 and 10 inclusive. The field will enforce these validation rules during model instantiation, ensuring the risk value stays within the specified bounds.
Support agent equals agent #1.
creates an instance of the Pydantic AI agent class and assigns it to the variable support agent. The line shows the beginning of an agent constructor call, though no parameters are visible in this segment. The agent serves as the primary interface for interacting with language models, containing instructions, tools, and configuration for AI-powered operations.
OpenAI GPT-5 2
specifies the model identifier OpenAI GPT-5 2 as a string literal, likely used to configure which LLM model an agent will use for inference. The comment 2 suggests this is part of an ordered list or documentation reference point.
Deps type equals support dependencies.
Sets the dependency type constraint for the agent to support dependencies, which defines the type of dependencies that dynamic instructions, tools, and output functions can use during agent execution. This parameter ensures type safety by enforcing that all dependencies passed to the agent must conform to the support dependencies type.
Output type equals support output, #9.
Sets the output type for the agent to support output, specifying that the agent's response must conform to this structured output type. This ensures type safety and guarantees the return data will match the support output schema when the agent completes its run.
Instructions equals #4.
Starts defining a tuple named instructions with a comment indicating this is item 4 in a sequence. The opening parenthesis suggests this is the beginning of a multi-line tuple definition, though the actual instruction content isn't visible in this segment.
You are a support agent in our bank. Give the
defines a partial string literal containing the text, "You are a support agent in our bank." Give the, which appears to be the beginning of an instruction or prompt for an AI agent. The string is incomplete, ending with a trailing space, suggesting it would be continued or completed in subsequent code. This appears to be setting up static instructions for a Pydantic AI agent that will operate in a banking support context.
Customer support and judge the risk level of their query.
This line describes the purpose of an AI agent in a customer support context, specifically to evaluate and categorize the risk level associated with customer queries. It suggests the agent is designed to analyze support requests and determine their urgency or potential impact, likely as part of a triage or prioritization system. The focus is on assessing risk rather than providing direct solutions to the queries.
At support agent instructions #5.
Decorates a function with the @support agent instructions decorator, marking it as a dynamic instructions provider for the support agent, Pydantic AI agent. This function will be called during agent execution to generate runtime instructions that guide the LLM's behavior, with the instructions being reevaluated on each run rather than cached from previous executions. The decorator integrates the function into the agent's instruction pipeline, ensuring its output is included in the prompt sent to the model.
Async def add customer name tags. Run context support dependencies, SDR.
Defines an asynchronous function named addCustomerName that accepts a run context parameter typed with support dependencies and returns a string. The function is designed to work within Pydantic AI's agent execution framework, where CTX provides access to dependencies and runtime context during the agent's operation. The return type annotation indicates this function will produce a string output when called.
Customer name equals await CTX, deps, DB. Customer name it equals CTX, deps, customer ID.
Asynchronously retrieves a customer name by calling the customer name method on a database dependency accessed through the run context, CTX, deps db. The method is invoked with the customer ID obtained from CTX, deps customer ID, and the result is assigned to the variable customer name. This operation waits for the database query to complete before proceeding.
Return F. The customer's name is customer name R.
Returns a formatted string containing the customer's name, using the R conversion flag to apply repr on the customer name variable. This ensures the name is displayed with quotes and any special characters are escaped, providing a clear representation of the string value.
At support agent tool #6.
Decorates the following function as a tool for the support agent, making it available for the agent to call during execution. The decorator registers the function as an available tool that the LLM can invoke when processing requests, enabling the agent to perform specific tasks defined by this function.
Async def customer balance.
Declares an asynchronous function named customer balance that will execute as a coroutine when called. The function signature is incomplete in this segment, showing only the opening line with no parameters or return type annotation visible. This establishes that the function will support non-blocking I/O operations and can be awaited in an async context.
CTX. Run context support dependencies, include pending, bool.
Declares two function parameters, CTX of type run context support dependencies and include pending of type bool. The CTX parameter provides runtime context including dependencies, messages, and usage statistics, while include pending is a Boolean flag likely controlling whether pending items should be included in the operation.
Returns the customer's current account balance, #7.
This docstring describes the purpose of a function that retrieves the current account balance for a customer. It serves as documentation explaining what the function does when called.
Return await CTX, deps db customer balance.
Returns the result of an asynchronous call to customer balance method on the database dependency accessed through the run context. The await keyword indicates this is in an async function, pausing execution until the database operation completes. The method appears to retrieve customer balance information, with the actual implementation details handled by the database dependency.
ID equals CTX, deps customer ID.
Assigns the value of customer_id from the deps attribute of the CTX object to a variable named id. This extracts a specific dependency value from the run context for use in the current scope.
Include pending equals include pending.
Passes the include pending parameter to a function or method call, preserving its value for controlling whether pending items should be included in the operation. This is a straightforward parameter forwarding that maintains the caller's intent regarding pending item inclusion.
Async def main.
Defines an asynchronous function named main that serves as the entry point for the program's execution. The async keyword indicates this function will contain non-blocking operations, allowing other tasks to run while waiting for I/O or other asynchronous operations to complete. The empty parentheses suggest this function currently takes no parameters, though it may be modified later to accept arguments.
Deps equals support dependency customer, ID equals 123, DB equals database con.
Creates a support dependencies instance named deps with a customer id of 123 and a DB parameter initialized to a new database con object. This sets up a dependency container with specific runtime values for customer identification and database connectivity.
Result equals await support agent, Run what is my balance? Deps equals deps hash 8.
Asynchronously executes the support agent with the prompt, "What is my balance?" and passes the dependency's deps to the agent's run method. The result of this execution is stored in the variable result. This is an asynchronous operation that will return a run result containing the agent's response to the given prompt.
Print result, output hash 10.
Prints the output property of the result object to the console. The comment indicates this output corresponds to the value 10, suggesting the agent's run produced this specific numeric result.
Support advice equals hello John. Your current account balance, including pending transactions, is $123.45. Block card equals false risk equals 1.
Assigns 3 variables. Support advice with a customer support message containing account balance information, block card as a Boolean flag set to false, and risk as an integer set to 1. These appear to be configuration or state values for a financial support system, where support advice holds the message template, block card indicates whether card blocking is enabled, and risk represents a risk level assessment.
Result equals await support agent. Runny just lost my card. Deps equals deps.
Asynchronously executes the support agent with the input message, "I just lost my card," and passes the deps dependencies to the agent's run method. The result of this execution is stored in the result variable.
Print result, output.
Prints the output attribute of the result object to the console. The output attribute contains the final value returned from running an agent, which could be plain text, structured data, or the result of a function call.
Support advice equals, I'm sorry to hear that, John. We are temporarily blocking your card to prevent unauthorized transactions. Block card equals true risk equals 8.
Assigns 3 variables. Support advice gets a string message about temporarily blocking a card. Block card is set to Boolean true, and risk is assigned the integer value 8. These appear to be configuration or state values for a card blocking operation, with the message explaining the action to the user, the Boolean flagging the block action, and the risk level quantifying the threat severity. This implementation showcases Pydantic AI's dependency injection system in action, where runtime dependencies like customer IDs and database connections are cleanly separated from agent logic. The support dependencies, data class serves as the bridge between external systems and the agent's execution context, enabling type-safe access to resources through the run context parameter. The agent combines static instructions with dynamic context. The base instructions define the agent's role as a bank support assistant, while the @support agent instructions decorator injects personalized customer information at runtime. This dual approach allows for consistent behavior across runs while maintaining personalization. Structured output validation through the support output Pydantic model ensures the agent always returns predictable, machine-readable data with enforced constraints like the risk level's 0-10 range. The tool registration pattern demonstrates how agents can perform specific tasks like balance checks while maintaining access to dependencies through the same run context interface. The key insight here is how dependency injection creates a clean separation of concerns. The agent logic remains focused on decision-making, while external resources are injected at runtime, making the system more testable and maintainable. The combination of dynamic instructions, tool functions, and structured output creates a robust pipeline that's both flexible for different customer scenarios and reliable for production use.
The silent decorator hands the agent a blank scroll. Yet it returns structured wisdom and blocks stolen cards.